Okay, hello. So we're going to have a go at this quiz. First thing we need to look at is the context. So if we have a little read, it's about two diets comparing mean cholesterol levels across the two. Now it might sound familiar, it is. This is the example from the end of chapter 7 and it was done in the last lecture of chapter 7. So if you've got any further questions, that's a good lecture to go back and rewatch. So getting into the nuts and bolts of this, here is our observed differences. These differences are calculated by going x bar 1 minus x bar 2. So the observed mean for diet 1 minus diet 2. This means that any positive numbers we get for this difference are telling us that diet 1 has the higher cholesterol on average. And we're assuming for this example that high cholesterol is bad. So that would mean that diet 1 is the bad one. Negative numbers, that's going to tell us that diet 1 is better, because it's giving the lower cholesterol. Okay, dropping down a bit more into our questions, we've got our hypotheses here. We could also write these in symbols using mu for the parameters. And our alternative hypothesis here is two-sided. We've got no reason to know which way round it's going to go. Two-sided is always a safer alternative. So part A, what is the hypothesized value? Well, we can see it sitting right there. It's 0. B, we're having to complete a sentence. The estimated difference in case 1 is some number of standard errors above or below the hypothesized value. Well, how on earth can we work that out? Well, we could do a little calculation, but that might get tricky. We actually know what calculation we have to do, and that's that we need to calculate the test statistic. The reason we need to calculate that is if you look in your glossary, in your blue pages under test statistic, the test statistic T0 specifically calculates how many standard errors above or below the hypothesized value the estimate is. So the estimate in case 1 is 2, our hypothesized value is 0, and our standard error is 0.5. So that comes out to be 4. Test statistic of 4 means that the estimate, 2, is 4 standard errors above the hypothesized value. If it had come out to be -4, then that would tell us that it was 4 standard errors below the hypothesized value. But we have a positive number here. Okay, question C is asking about statistical significance. Statistical significance refers specifically to the p-values. And in this case, our significance level is 5%. So any p-value less than 5% or less than 0.05 is going to be deemed statistically significant. So in this case, when we look at our 5 cases, the top 3 have p-values less than our significance level. So which cases are statistically significant? Cases 1, 2, and 3. The next question is asking about practical significance. So for this, let's go back and read the question again. This information here is telling us about practical significance. A difference of less than 10 is not important, not practically important, but anything 10 or more is. So looking just at our estimates, the only differences that come up as bigger than 10 are on cases 2 and 3. But that's not enough just looking at that. We actually need to look over at our confidence intervals. And what we want for practical significance is a whole confidence interval sitting above the level of practical significance. So the easiest way for us to do this is to jump over to our confidence interval visualization tool, which was demonstrated in lectures and is also linked in the information about the quiz. So if we jump over there, we can put some information in. A parameter is difference between two means. Watch out for that one. You will need to change it if when you do the quiz you come up with a slightly different question than that. Hypothesized value, for us that's 0, so that stays as it is. For single mean and single proportion, we might often get a hypothesized value that is different from 0. It says there in the hint, check the null. Values of the parameter that are considered practically important, anything lower than -10 or higher than 10. So let's put in our confidence intervals. Three. And update our visualization. Here we go. So what can we see going on here? Well, anytime that we have a confidence interval that sits entirely in the green zone, that means all the way along that confidence interval, we have practically significant values for the difference. So this one here, case 2, entirely practically significant. Cases 1 and 4, where we've got the entire interval sitting in the white zone, that means nowhere along that confidence interval could we have a value of the parameter, a value of the difference between the two means, as 10 or more. Case 3, a little bit more interesting. In this one, up at this end of the confidence interval, we have a difference that's more than 10, that's practically significant. But down at this end, the difference is not practically significant. So this one's hard to tell. We don't really know whether it is practically significant or not, because the true value of the parameter could be anywhere along that interval. This last one, case 5, well, it could be practically significant, or it might not be, or it could be practically significant the other way round. So up at the positive end, this tells us that diet 2 has the lower cholesterol level. So in that one, diet 2 looks practically, importantly, better, but down this end, diet 1 is better. So we've got conflicting information. It might be practically significant, it might not. It might be good to recommend diet 1, or it might be good to recommend diet 2. Let's put this into our answers. Which ones have practical significance? That was only case 2. That's the only one we could see for sure that was sitting all above in the green section. Which ones do not have practical significance? That was 1 and 3. Those are the ones that were sitting totally in the white zone. And case 5 was the one where we'd learned nothing useful. It could have been anything. Final example is looking at this extra additional case here. So let's have a look at what we can see. Firstly, with our estimate, it's negative, which is indicating to us that diet 1 is better. Right, diet 1 having the lower mean cholesterol level. Our p-value, 0.06, is higher than the 5% cutoff for statistical significance in this case. So this is not quite statistically significant. If we were interpreting this in a different way, we could say that there is weak evidence. Weak evidence against the null, weak evidence of a true difference between the mean cholesterol levels for the two diets. And let's draw out our confidence interval. So it goes from 2 all the way down to -62. So 0 is sitting here, -10 is sitting here. So everything through this region would be practically significant. 0 is a possible value for the parameter, which means there could be no mean difference between the two diets. And 2, or a positive value, is also a possible value for our parameter, which means that diet 1 could actually be a little bit worse. So let's answer our questions. So the difference is not statistically significant, and we are not able to claim that the difference has practical importance. It might, but it also might not. With 95% confidence, the mean serum cholesterol level for diet 1 is estimated to be somewhere between 62 milligrams per deciliter lower, so that's looking at this end here, it's negative, showing that diet 1 is lower, or up to 2 milligrams per deciliter higher, because that end is positive, so we've swapped from lower to higher. Based on these results, would we be able to make a recommendation? So this is a really difficult one to answer. If we recommend diet 1, what's the worst that will happen? The worst that will happen is that either it has absolutely no effect at all, or it has a slightly worse effect, but not an effect that has any practical importance. What's the best that will happen is that it has a really practically important benefit. So in this case, our pros kind of outweigh our cons, and we could recommend diet 1. So that's our tutorial for this quiz. Remember, if you have any further questions, it's good to re-watch the lecture at the end of chapter 7, which goes through this example in the lectures. Once you're feeling a bit confident, you can go and try the actual quiz.